Deep in the southern constellation of Fornax, there exists a world that should not be able to exist. It is a giant planet stripped entirely naked, a colossal planetary skeleton orbiting so close to its parent star that its year lasts less than a single Earth day. This is TOI-849b, the first discovered remnant core of a gas giant planet. It is a dense, scorched ball of iron and rock, completely devoid of the thick, protective atmosphere that usually defines worlds of its immense size. For astronomers, finding this object was like discovering a fossilized dinosaur skeleton still warm to the touch, offering an unprecedented look at the hidden interior of a giant planet. Discovered in 2020 by an international team of astronomers using NASA's Transiting Exoplanet Survey Satellite, or TESS, TOI-849b sits roughly 730 light-years from Earth. To pinpoint its precise nature, researchers utilized the high-accuracy radial velocity planet searcher instrument, located at the La Silla Observatory in the high, dry desert of Chile. As the planet crossed the face of its host star, it blocked a tiny fraction of the stellar light, revealing its physical size. But when scientists measured how much the planet tugged on its star gravitationally, they were shocked. The object was far too heavy for its size. It was a world of pure, concentrated planetary bone, challenging our deepest assumptions about how cosmic bodies grow and evolve. The physical characteristics of TOI-849b defy standard expectations of planetary physics. The planet is roughly 3.4 times the size of Earth, making it slightly smaller than Neptune. Yet, it possesses a staggering 40 times the mass of Earth. This extreme density tells us that TOI-849b is not a fluffy ball of gas, but a massive, solid world composed primarily of iron, silicates, and nickel, with a density comparable to Earth's own metallic core. It orbits its host star at a blistering speed of over 220 kilometers per second. At this velocity, the planet completes a full orbit in just 18 hours. Because of this extreme proximity, the stellar radiation hitting the planet is absolute. If you stood on this exposed core, the heat radiating from the ground would reach 1500 degrees Celsius, a temperature hot enough to melt steel, copper, and gold. The sky above you would not be a gentle blue, but a glaring canopy dominated by a sun 60 times larger than ours, blistering the rocky landscape below. Under your feet, the immense gravity would pull on your body with more than 3 times the force you feel on Earth, making every movement an agonizing struggle against the crushing mass of the planet. Under such extreme conditions, any normal planet would have withered. But TOI-849b is no normal planet. Its discovery directly challenges our core accretion model of planet formation. According to this model, any planetary core that reaches 10 times the mass of Earth should rapidly pull in vast amounts of hydrogen and helium from the surrounding protoplanetary disk, ballooning into a gas giant like Jupiter. TOI-849b is 40 times the mass of Earth, meaning it easily crossed this threshold. Yet, it has virtually no gas envelope. How a planet can grow this massive and lose its entire atmosphere, or fail to gather one in the first place, is one of the most compelling mysteries in modern astrophysics, forcing scientists to rewrite the textbooks on planetary evolution. Scientists have proposed 2 primary theories to explain this cosmic anomaly. The first theory suggests that TOI-849b was once a magnificent gas giant, perhaps even larger than Saturn. In this scenario, the planet migrated too close to its host star, and the intense stellar wind and radiation stripped away its massive envelope of hydrogen and helium over billions of years, a process called photoevaporation. Alternatively, a catastrophic event, such as a giant collision with another massive planet, or tidal stripping as the planet ventured too close to the star's gravity, could have violently peeled away its outer layers. The second theory is even more intriguing. TOI-849b might be a failed gas giant. It may have formed its massive, rocky core in a region of the protoplanetary disk that was suddenly depleted of gas, perhaps cleared out by the newly ignited star. In this case, the planet grew its colossal skeleton but was starved of the materials needed to grow its outer atmosphere, leaving it forever exposed to the harsh vacuum of deep space. Understanding the true history of TOI-849b is crucial because it allows us to peer into the deep interiors of planets that are normally forever hidden from our sight. In our own solar system, we can only guess at what lies deep beneath the thick, swirling clouds of Jupiter and Saturn. We cannot penetrate those thousands of kilometers of metallic hydrogen to touch the rocky cores beneath. TOI-849b removes the veil, offering a natural laboratory to study the high-pressure physics of planetary interiors. Everything you have ever seen on Earth, from our tallest mountains to our deepest oceans, exists on a thin, fragile crust. TOI-849b represents the opposite extreme, a world that is nothing but interior, exposed to the harsh vacuum of space. As next-generation instruments like the James Webb Space Telescope continue to study this battered remnant, we are forced to redefine our understanding of how worlds are born, how they die, and the violent forces that shape the architecture of the cosmos.